Good evening. Let's go through another important topic, that is Phasor representation of alternating quantities. Alternating quantities such as voltage and so alternating quantities, voltage and current are not actually vectors. They are phasors. They are given the name phasors. Phasors can be represented in four different forms, that is rectangular, trigonometric, polar and exponential form. Out of these, rectangular and polar form are the two important ones. First, let's go through the rectangular form representation of a alternating quantity. We know that a vector a vector v can be represented as component of two functions, that is x and y, where x is a x-axis coordinate and y is a y-axis coordinate. And this is a representation of vector v. X is x-axis coordinate and so y1 is a y-axis coordinate. And the angle between x-axis and the vector is marked as theta. Then from mathematics, we know that the magnitude of the vector is given by root of x1 square plus y1 square, and theta is given by tan inverse y1 by x1. So this is a rectangular form representation of the vector. Next, trigonometric form. Trigonometric form is nothing but representing the vector as trigonometric functions. That is, I can represent trigonometric function as vector v can be represented as v cos theta plus j sin theta v. V cos theta plus j sin theta. This is a rectangular representation. Trigonometric representation. That is, v cos theta is nothing but x and v sin theta is nothing but y. This is a trigonometric representation of this vector. This is a trigonometric representation. This is a rectangular representation. Next one, what do you mean by polar form? Polar form is nothing but representing the vector with its magnitude and its angle with x-axis. That is, in simply, polar form can be represented as v angle theta, where v is a magnitude of the vector given by v is equal to root of x1 square plus y1 square. The magnitude of the vector is given by, and theta is the angle with which the vector makes with x-axis, that is tan inverse y1 by x1. From this two expression, we can clearly understand the relation between rectangular form and polar form. So this is a representation of a phasor in polar form. This is a third representation in polar form. And next one is trigonometric form. Trigonometric form is next one is exponential form. Exponential form is representing the vector as exponential power. We know that exponent E angle j theta is given by cos theta plus j sin theta, or E angle j plus or minus j theta is given by cos theta plus or minus j theta. From this expression, I can represent a vector in a form v e raised to plus or minus j theta. This form is known as exponential form of vectors. This is nothing but E angle j plus theta is equal to cos theta plus j theta. This is nothing but v cos theta plus or minus j sin theta. This is equivalent to the trigonometric representation as just representing the total vector as an exponential function. So these are the two important representations, that is rectangular form, trigonometric form, polar form and exponential form. And we can simply convert polar form into rectangular form into polar form by using calculators, or simply using the expressions. Magnitude is given by this expression and phase or theta is given by this expression. Thank you.